The following is the video solution from JSDT Solutions. Question 7.1 says, an investment earns interest at a rate of 7.5% per annum compounded quarterly. Calculate the effective annual interest rate of this investment. Okay, so we are dealing with nominal and effective interest rates. So just a brief background on this. The nominal interest rate is what you are quoted, and then the effective annual interest is the interest rate you actually get when you look at that compounding for the full year. Okay, so the effective interest rate is usually going to be more. And the reason why is because interest builds on interest. Okay, and so because of that, at the end of the year, that interest rate is actually more than what they quoted you. Okay, so with that, you can see that they asked us to calculate the effective interest rate, meaning they have given us a nominal. Okay, so here's the formula. It's simply 1 plus I effective. Now, normally you'll see this formula say to the power of 1. It's just because it's per annum, but we don't really need to write that 1. So it's equal to, and we'll say 1 plus I nominal. Now, this has a compounding, so it's over n raised to the power of n. Okay, so we're finding the I effective and what is the nominal we were given. We were told that the investment earns interest at the rate of 7.5% per annum compounded quarterly. You will notice that the nominal will always have a compounding quarterly, monthly, semi-annually, and so on. Okay, so we're going to say 1 plus, and we'll write that interest rate as a decimal, which is 0.075. You can always just say 7.5 over 100 and then convert it into decimal notation. So this is over n, so it's compounded quarterly, meaning we're going to divide this by 4 so that it earns interest every quarter and then raise to the power of 4. And now all we have to do is make I effective the subject. So this is I effective is equal to, and then 1 plus, we're just going to rewrite everything and then just put this on the calculator. It's first going to give us a decimal. So transpose that 1 and it's negative. And let's find the answer. Okay, so let me write it as a decimal first. So this is equal to 0.0771. Okay, and then it needs to be written as a rate. So multiply it by 100. So if we take that and we multiply that answer by 100, we get the effective interest rate is 7.71%. Okay, and then you see that we had 7.5%, but now it's 7.71%, okay, which is higher. And that is our answer. Moving on to the next question. Question 7.2 says, rhino poaching is a serious problem and has resulted in the black rhino becoming an endangered species. Statistics show that there were 60,000 black rhinos in 1970 and only 4,200 remaining in 2011. Determine the annual rate of population decrease as a percentage over these 42 years. Okay, so they're asking for a rate. If the rate is compound decay. Okay, so they really told you everything here. So we see that we're using compound decay, which the formula looks like this. A equals P times 1 minus I raised to the power of n. Okay, so the starting amount, we started off with 60,000 black rhinos in 1970. So that is the amount we start off with. It was 60,000, and then they went down to 4,200 in 2011. So this is the amount we have ended at in 2011. And then we'll say 1 minus, and the interest is what we're trying to look for. But do you notice that they said determine the annual rate? So this is not compounded monthly or anything like that. The annual rate, okay? We want to see that decrease per year. So we can simply say I and then raise to the power of how many years are we looking at? They even told us the years. They didn't even make us calculate it. They said over these 42 years. So raise to the power of 42. So all we have to do is solve for I. Okay. So how do we find I? We just need to get closer to it. you need to get rid of the 60,000 first. So we can divide both hand sides of this equation by 60,000 and 60,000. And might as well just start dividing now. So cancel out 2 zeros, cancel out 2 zeros. So just say 42 divided by 600 so long. Okay, so 42 is a multiple of 6. So 6 is a common factor. It's actually the highest common factor. So we can just say 42 divided by 6 is 7 over, and then 600 divided by 6 is 100. 7 over 100 is equal to, this cancels, and we have 1 minus I raised to the power of 42. Now we're still trying to get to the I. So we're going to get rid of that power of 42. So we will find the 42nd root of both hand sides. But I'm not going to find that answer. I'll leave it like that because I don't want to work with decimals for now. And so this breaks open. And now we have here, we have 1 minus I is equal to, again, the 42nd root of 7 over 100, and then we can transpose the I since it's negative. So it now becomes positive I, and we're saying this is equal to 1 minus this value. And that's all we have to find. So let's just find this on the calculator, and then of course rewrite it as a rate. So that is 0.0613, and then if you multiply this by 100, so equal to multiply by 100, and now we have that rate that they were referring to, we can just tell them that the rate is, and this is 6.14. It's going to round up 6.14% per annum per year. And that is our answer. And we move on to the next question. Question 7.3 says, Adam inherits 27,000 Rand, which he invests in a savings account. Okay? And then they say the interest is calculated at 5.4% for the full period. Then, 3 years later, okay, after he invests the initial amount, he withdraws X Rand to make a down payment on a car. Calculate the value of X if he accumulated 17,614.76 cents in the savings account after 10 years. So from this question, you see that this is not a future value question, okay? Someone is not saving money every month or depositing money into an account every month. There's one amount, 27,000, which he inherits. And then he gets this amount and he invests it, right? Then we know that this savings account, it lasts for 10 years because they told us after 10 years, he has this amount. So at T10, he has 17,614.76 cents. We also know the interest is 0.054 compounded monthly, so over 12. And we are told that after 3 years, okay, so from this, you can see that this is not a future value question because one amount is invested and then, of course, he makes a withdrawal. This is a timeline question. So with timelines, it's easier to start at T0 because you can monitor the interest that is gained, okay, per time period. So I'm looking at these as years. So at T0, this is where he invests the money. Then after a year at T1, it's going to gain interest worth 1 year. So what they tell us is that 3 years after he invests this, then at T3, okay, then he withdraws money. X Rand is taken out of this account. Okay, so here he invests, here he withdraws. And we already know the total amount in the account. So we need to find out how much he actually took out. So here is the story with investments and withdrawals in timelines and really just in accounts. When you invest money, it's not just that amount that is there at the end, it's that amount plus interest. But when you withdraw money, the same applies, okay? You withdraw money, great, yeah, but then the interest that money was supposed to make is also gone. So we're going to have to look at it like that. So with every entry point, here we have 27,000 going in. That's what we're going to look at to start our calculations. So it's still compound interest growth. Money is still being invested. So we're going to use A equals P times, 1 plus I raised to the power of N. Okay, so we can just say A is equal to, and the amount invested first is 27,000. Now you're going to have to look at each of these. So what I mean by entry points are like the money invested, the money taken out. You're going to have to look at this and see the story with it. This amount was invested at this interest rate, but how long did it stay in the account for? Because it came in at T0, it's going to stay for a total of 10 years. So we're going to say 1 plus the interest is 0.054 over 12 raised to the power of, it stays for 10 years. But of course, this is compounded monthly. So we say times 12, okay? So it gains interest every month. Then the next thing that happens is he takes out money. So we'll say minus the amount he takes out, which is X. The interest he takes out also leaves. So we'll say 1 plus 0.054 over 12 raised to the power of. Now, how many years worth of interest is this money losing? It left the account at T3. So that is 7 years worth of interest, 10 minus 3. So that is 7 years multiplied by 12. Okay, so this is what our timeline looks like. And this is the calculation. But we also know that at the end of the period, he ends up with this amount. And that is our accumulated amount. So that is the 17,614.76. Okay. And now all we have to do is look at this and look for the neatest way to simplify it. So first, I see that this is negative. We might as well transpose it to make it positive. So now it is positive X multiplied by, you see, this is repeated. So we might as well just find the value of that fraction. That's simply going to be 1 plus 0.054 over 12. Okay, it gives a nice decimal. If not, I was going to take it as a fraction, but the decimal is fine. So 1.0045, okay? And then raised to the power of that amount, because it says 7 times 12, you might as well just say 7 times 12 is 84. So raised to the power of 84, and then is equal to, and now that this has come to the left-hand side, what are we left with? We're still left with this on the right-hand side. So we'll write this as 27,000. And then this is 1.0045 raised to the power of, that's 120. And then we can just take this over. So we're transposing this, which is 17,614.76. Okay, so at this point, you see that in order to get to X, all you have to do is get rid of this number. And this is being multiplied to the X. So we need to divide by it to get rid of it. So we'll simply divide both hand sides by this number. So X is equal to, and I'll rewrite all of this and then let's put it on the calculator. Okay, so our answer is finally X is equal to, and it is 19,656.28 cents. And that is our answer. Okay, and that is it for the financial math section of this paper.